So now in this video, I'm going to talk about a problem that comes up from time to time. So we have, in this case, an LED that we want to light up. Obviously, we want the LED to be bright enough, so we're going to need enough current to go through it. If we are using a 12-volt power supply, then I think kind of the minimum resistance you're going to want is a 1,000 ohm resistor. And the reason why is because most resistors are quarter watt, and they will overheat if they get too much wattage. So recent videos we looked at the 1,000 ohm resistor, but I did some math down here. So the LED is going to drop about 2 volts, and from my earlier video I saw I only want to put about 11 volts across the 1,000 ohm resistor. But in any case, we'll get about 0.01 amps of current. When you times that 10 volts times 0.01 amps of current, that's 0.1 watt right there. So quarter watt resistors have a maximum of 0.25 watts, which is quite a bit more than this, but you should still stay below half of that, 0.125 watts, which is just a little bit above what we're going to get in this particular circuit if we wire it up. So the resistor should not get too hot as long as it has adequate air exposure to it and whatnot. But in any case, we got about 10 milliamps of current, which may be fine, you know, for a red LED. But maybe it won't be quite bright enough, and you're going to want some more. So whenever you run into that problem, I don't want to use a lower value resistor because it's going to get hotter with this 10 volts across it. It's going to let more current flow through. That's going to create more heat, but we want more current for the red LED. So simplest solution right here is a second resistor right there in parallel. So each one of them will have 10 volts across them, as indicated by there. No matter what we do up here, the LED is going to build up about 2 volts across it, as long as the supply voltage is more than 2 volts and other components don't drop voltage. Resistors don't drop voltage, they accept whatever voltage comes across them. So we're still dropping 2 volts. Now, though, each of these resistors has 10 volts across them. Each one's going to let about 10 milliamps of current flow through them. And for those that like pictorials, I drew a pictorial over there of the circuit right there. So those are whatever the leads or whatever, maybe there's a jumper or something going to the positive supply there. And then when it comes to the short lead, the cathode of the LED, you got to put it in the right way or it won't light up. It's headed directly to the negative supply there. You can measure current or not. This just indicates the approximate current you're going to get. Anode connected to the side of the resistors that are not to the positive supply. So current flows through both of them as if the other one doesn't exist. They both just see 10 volts for the most part. And then the current combines, goes through the LED. So each one's only passing 10 milliamps of current. Sometimes I write that there, but I think that makes it kind of cluttered. So probably better to do this way. Just realize they combine. So you can keep adding resistors in parallel to combine their current. Of course, LEDs, these indicator LEDs, the little ones that I use in most of my circuits, they have a maximum current of 20 milliamps of current. So red LEDs drop about 2 volts, blue LEDs drop about 3 volts, so they would have 18. A blue LED would have 18 milliamps of current flowing through it, because each one of the resistors would add 9 volts across it. Blue LED drops 3 volts. Resistor would have 9 volts, and therefore 9 milliamps of current times 2 is 18. So hopefully that makes sense. It's really easy to look at something like this and swap out the numbers pretty quickly. You don't have to write it all out. But you know, if you have to, you have to. So in any case, we could keep adding resistors to get more current. So that is the main solution for when you hit the limit of your resistor when it comes to the wattage. You know, if you need, in this case, to make the math easy, twice as much current is what you can get out of a particular resistor, because going lower in resistance will overheat the component. Just put some in parallel. That's the basic premise of this circuit, of this diagram right here. Now, 20 milliamps is a lot for an LED, so we're going to expand on this a little bit more. So 10 milliamps might be a little too low. Might be fine actually, but might be a little too low. So you want more, but you don't want to go all the way to 20 milliamps of current. Very easy. Instead of 1,000 ohm resistors, use 1.5. At least that's what I have in my kit. I don't know what all resistors you will have. I think there's 1,000, 1.5, and then 2,000. Maybe there's some other values, but I think above 1,000. 1.5 is the next one. So that's going to give us a little more than 6.5 milliamps of current. So that's lower. That may not sound too good at the moment. We're going to make the math easy. 6.5 milliamps, just slightly higher than that. But if you parallel to 1.5K, then each one of them is going to have about 6.5 milliamps of current going through them. They're going to combine for about 13 milliamps of current. It's going to be slightly more than 13 milliamps of current, which is what I normally have when I light red LEDs at lower voltages with a lower value resistor, 220 ohms. Usually I get a little more than 13 milliamps of current. So that would work out perfect. Again, 1.5K on each of these. So I didn't demonstrate that on this diagram, but it was that easy for me to convert it. You know, I got that basic. You got the current of one resistor right there, because the LED doesn't set current, just drops some voltage. You put 2, it doubles it up. So very simple. You know, if I got about 60% of the current of one, I can double that, and we'll get 60% of what this is right here. You know, it's you know, not complex math once you get a little familiar with it. So in any case, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help a lot. I'll see you in the next video.